So this is page 12, 13, and 14. If you're printing them from Google Drive, just print those pages because we're not going to do the entire packet, so don't waste paper. Dr. Conklin has a video that's also posted right next to this. That's the same exact notes, just on blank paper, but you can watch either one, just whichever one makes more sense to you. I'm going to do it off of these though. Central and inscribed angles. Those are words that should have come up when you did your notes and uploaded them, and if you were on the Kahoot that we played earlier yesterday, then you would have known those two words. So a central angle, I like to make the angles bigger than they really are, or longer. This arc, this curved arc, is a 70-degree arc, meaning if you curved your way all the way around the circle, it would be a 360-degree arc. But that much of it is 70 degrees. The angle that is formed inside there is exactly the same as whatever the arc is. So if that is 70 degrees on the arc, it is 70 degrees for the angle. Central angles and their arcs are always exactly the same number. Questions 2, 3, and 4 have to do with this picture. Question 2 says, how big is the measure of arc AC? Well, if this is 100, then so is that arc. It's 100 degrees of an arc from here to there, because this angle was 100. Number 3 says angle COB. Angle C to O to B. Well, if this side's 100, then that side must be 80, right? And arc A to C to B. The reason they gave you 3 letters there is because it wants you to go from A to B, but it wants you to travel through C on your way there. So A to C to B would be, how far is it from here? I shouldn't say how far, but what's the arc from A all the way around to B, but if you traveled through C? Well, it's exactly half the circle, right? Because this is the diameter. So that's a semicircle, so it's 180. All right. Number 5 is a little complex, because what we have here is a radius, another radius, and all radii are the same, right? If I draw a radius here, or here, or here, or here, they're all exactly the same length, which means that this must be an isosceles triangle. And if this angle up here is 50, so is this one down there, because that's what isosceles triangles have. 50 and 50 is 100. That leaves 80 left over, right? Because you need 180 to make this triangle in here. So 50, 50, 100, another 80. And then it wants to know the value of x. Well, here's a line. That's 180. So you must have 100 on the other side, right? 80 on the right, 100 on the left. That's a little, not advanced at this point. You shouldn't have known that. I wouldn't expect you to know that right away. So you're just kind of following along. This one here, when it's marked 270 up there like that, what they're doing is, if they said 270 was here, which wouldn't make any sense, but they would be talking about this, but they're not. The 270 is written up here. So that means it's the huge arc going from here all the way around to here. So if an entire circle, right, is 360, and we've already used 270 of it, whoa, that means there's 90 left over. And there's that central angle again. So if that's 90, so is that. So x is 90. And then this is kind of the opposite situation. They're telling you that 70 is in a really weird spot. I hate the fact that they typed it where they did, because are they talking about that angle? Are they talking about that arc? Well, luckily it doesn't matter, right? Because that's 70 and so is that because it's a central angle. So it really doesn't matter, I just don't like where it is. If an entire circle is 360 and we've used 70 of it, that means we have 290 to go all the way around here. So that big arc up there is 290 because that much was 70. Number 8. I like to extend these again, right? But don't forget that this and this are radii, so like that's the same as that, which means those two angles have to be the same, right? So if I have 180 in a triangle and I used 80, that leaves me with 100, which means both of these must be 50, which makes the answer for x 50. Okay. All right, page 13, same type of thing. In fact, number 9 is not too different than number 8. Instead of, it's the same type of picture, but remember we have an isosceles triangle, which means, and why is it isosceles? Because those two sides are both circle radii, and radii have to be the same. So 55 and 55 is 110. That leaves me with 70 for x. Number 10, similar to 2 problems ago. If that is 100 up here, that leaves me with 80. But I need to split it evenly because this and this are the same. So x and x are the same. Base angles, right? So those two are both 80. So x is 80. Here's our very first inscribed angle. So I would change my thinking here to inscribed. The reason it's inscribed is on every other one that we've done so far, the vertex was always at the origin. This one is on the edge. So this angle here is like chopped off like that. I always extend it. So this time, if this is 80, right, if that much of the arc from here to here is 80, the angle is no longer 80, it's now half of that. So inscribed angles are half of the arcs. Definitely write that. That's the first time this has happened. So when the inscribed means the vertex is on the edge, then the angle is half of the arc. So look, it happens again on number 12. This chops off this much of it, right? So if this arc from there to there is 220, then this angle would be half of that, because the vertex isn't in the center, the vertex is on the edge of the circle, so it's half. It is 110. Okay. 13, same idea, except this time they gave you the angle instead of the arc. Well, if this is 70, the angle's always half the arc. So the arc is the bigger thing, so that would be double 70, so it's 140, because the vertex is on the edge. It's inscribed. Same thing again, except this one just really wide. Really wide. So that entire angle intercepts that arc, right? From there all the way to there. So the angle is half of the arc. So the arc must have been twice 115, which is 230. Number 15 introduces a little bit of a curveball. Curveball. The only reason I say that is because they don't give you exactly what you need. Here's an angle, right? Now, there's something hidden in here. This is a diameter, right? Because it goes through the center, which means this is 180, which means this arc must be 100, because over here you have 80, so that must be the 180. So you don't really care about that 80 now, you just care that that must be 50. There's a little extra step in there. That one's really good to understand. And we get to do it again. Diameter, right, from here to here. So that means from here to here is 180. So this must be 60, because they told us this much of it was 120, so that much of it must be 60, which means that angle is half of that, 30. Page 14, we'll just keep hammering the same ideas here. This just gives us the information backwards. So we have a chopped off piece here. If this is 40, this arc here must be twice, because the angle is half. Well, if that's 80 and that's a diameter, then that must be 100. So x is 100. Almost the exact same problem here, right? You have a chopped off piece. If that's 60, then that arc is 120. Again, we have a diameter, 120 and 60. It's not because that's 60. It's because together they equal 180 here. Right, so that is 60. 19 looks fun. Maybe you noticed isosceles right away, right? Here's a radius. Here's a radius, which means that's the same as that. If this is 30, which it told us, right? Then that's 30. 30 and 30 is 60. So what's left? This one here is 120, right? Because an entire triangle, I'm talking about this triangle, would be 180. So if that's 120, what's right next door to 120? 60. A lot of isosceles going on with radii. Number 20. This one, there's two radii again, so that means we have an isosceles triangle, which means both of those angles are x. If this side is 40, then that side is 140. 180 minus 140 is another 40, which means both of those have to be 20 because they're isosceles. Base angles are congruent. 21 and 22, notice there's parallel lines there. Well, this is just two parallel lines cut by a transversal. You know this already. If this is 30, so is this, alternate interior. It's a little crazy, but this is 30, so this is 60. Well, the same thing happens on this side. That's 30, so that's 60. Now watch this. If this is the diameter, and we've used 60 and 60, which is 120, then that must also be another 60. Because 60, 60, and 60 is the 180 we're looking for. Same thing happens here. An interior here and here. So these would be 80. 80 and 80 is 160. So that top part is 20. 23 gets a little simpler again here. They're looking for ACB down here. The angle is always half of the arc when it's inscribed. Number 24, same thing. You're looking for ACB, the angle, the arc.